Hi everyone, it's Mrs. Marcellus, and today my guest is Pythagoras. Today we're going to go in search of the greatest common factor. The learning objective for today is the students will find the greatest common factor of two or more numbers by making a list or using factor ladders. Sound like fun, Pythagoras? Alright, well let's go to our vocab next. A factor is the number or numbers another number can be evenly divided by. For example, the factors of 12 would be 1, 2, 3, 4, 6, and 12. 12 can be divided by all of those numbers. The second vocabulary word is prime. A prime number has exactly two factors, 1 and the number itself. Some examples of prime numbers are 3, 7, 17, and 29. Of course, you can consult your sieve of Eratosthenes to find additional prime numbers. The final vocabulary word for today is greatest common factor, or GCF. The GCF is the largest number that two or more other numbers can be divided by. There are three common ways to find the GCF. One is to make a list, the second is factor trees, and the third is factor ladders. We will only be using make a list and factor ladders. Let's try our first problem. In the first problem, we want to find the greatest common factor of 6 and 14. One method we could use is to list out all of the factors and then find the greatest number that they share in common. To use the make a list method, you first need to list all of the factors of the numbers given. So the factors of 6 are 1, 2, 3, and 6. And the factors of 14 are 1, 2, 7, and 14. Next, we identify the common factors. They both have a 1 in common and a 2 in common. And the greatest of these common factors is 2, so the GCF is 2. We can also use the ladder method. In the ladder method, we set up the division problem, just like we did when we did prime factorization in class. Next, you put the two numbers inside the bracket. I need to find a prime number that goes into both of the numbers that are inside the bracket. Both 6 and 14 can be divided by 2. I write the 2 down on the outside, and then I do the division problem. 6 divided by 2 is 3, so 3 goes in the quotient, and 14 divided by 2 is 7. 7 will go in the quotient. I next look at those two numbers on top and decide if I'm finished or if I need to continue. The only common factor that both 3 and 7 have is 1. Since they cannot be divided by any other factors, I know that my GCF is 2. In this problem, we'll look at finding the GCF of 12 and 66. Using the make a list method, we would list out all of the factors of 12 and all of the factors of 66. You really have to know your factors if you're using this method. If you miss one, it could be the one that is the GCF, and if you don't include it in the list, you will get the wrong answer. Let's identify the common factors. 1, 2, 3, and 6 are common factors. Since the greatest of these common factors is 6, the GCF of 12 and 66 is 6. Let's try the ladder method as well. We set up the division problem and put 12 and 66 inside the bracket. Next, we identify a prime number that goes into both 12 and 66. You have two choices. You could use either 2 or 3 to start the problem. I'll go ahead and start with 2. 12 divided by 2 is 6. 66 divided by 2 is 33. Next, I look at 6 and 33. Since both of these numbers can be divided by 3, I need to continue the problem. 6 divided by 3 is 2. 33 divided by 3 is 11. The only common factor that 2 and 11 have is 1, so I know I'm finished. In order to find the GCF, I multiply the factors that I divided out. 3 times 2 gives me 6, so the GCF is 6. Next, let's find the GCF of 9 and 22. Using the make a list method, we would list out the factors of 9 and of 22 and then compare them to see what they have in common. In this case, the only common factor they share is 1. That means that the GCF is 1. Let's look at using the ladder method. I'll put 9 and 22 inside the division bracket. Since their only common factor is 1, I cannot divide at all. If this happens and you have two or more numbers that have a common factor of 1 and that's the only common factor they share, the GCF is 1. There's a special name for this when it happens. We call two numbers whose GCF is 1 relatively prime. It doesn't mean that those two numbers are both prime, because we can see that both 9 and 22 are composite numbers. They have more than two factors, but in comparison to each other, in relation to each other, they are relatively prime because the only common factor they share is 1. The GCF can be used to solve word problems as well. A gardener has 14 petunias and 35 daisies. She plants an equal number of each type of flower in each row. What is the greatest possible number of petunias in each row? For this word problem, I'm going to use just the ladder method. I will put both numbers inside the division bracket. Then I will divide out a common prime factor. The only number I can think of to use is 7. 14 divided by 7 is 2. 35 divided by 7 is 5. I next look at 2 and 5 and determine whether or not they have any common factors other than 1. They don't, which tells me I'm finished with the problem. The GCF of 14 and 35 is 7. That means that the greatest possible number of petunias the gardener can plant in each row is 7. There are 12 slices of cheese, 20 slices of pepperoni, and 8 slices of sausage pizza. If Euclid wants to make containers that have the same pizza assortment in them, what's the biggest number of containers he can make? And what is in each container? This too is an application of GCF, and I'll be using just the ladder method. I will first put all three numbers inside a division bracket. Next, I will look for a common prime factor to divide out, and since they're all even numbers, I think I'll use 2. And that would leave me with 6, 10, and 4 on top. I have 3 even numbers still, so I know I can divide by 2 again. After I divide, I have 3, 5, and 2. 3, 5, and 2 have only a common factor of 1, which tells me I'm finished. The biggest number of containers that Euclid can make is 4. That would be the GCF. Now I want to know what is in each container. The 12 was cheese, 20 was pepperoni, and 8 is sausage. The numbers across the top tell me the number that would go in each container. Each container would have 3 slices of cheese in it. It would have 5 slices of pepperoni and 2 slices of sausage. So, what'd you think, Pythagoras? Pretty easy, wasn't it? Hey, how about we go get some pizza? Maybe we can ask Einstein to join us. Bye, everyone.